I'm Glenda and in this video, I'll be covering my final year project. My project is titled Singapore-based Urban Knowledge Graph with Site Selection Application. So to start us off, what is a knowledge graph? Knowledge graphs are knowledge bases that use graph-based data models to represent and store data. They are typically used to model collections of interlinked concepts or entities with formal semantics. A key characteristic of knowledge graphs is the use of ontologies to categorize entities and relations. A subset of knowledge graphs are urban knowledge graphs, or urban KGs for short. Urban KGs are knowledge graphs used to model entities and concepts in urban spaces, such as cities. These urban KGs can be used in knowledge-driven paradigms to solve problems or tasks in urban areas. Unfortunately, there is a limited number of Singapore-based urban KGs to draw on, meaning that efforts to adopt knowledge-driven paradigms to solve Singaporean problems will be greatly hindered. This leads into the objective and scope of my project. There are two parts to my project. The first part is to construct a Singapore-based urban KG. More specifically, the urban KG would be centered around businesses, stores, and geographical regions in Singapore. The second part of my project is to implement an application of the urban KG. In this project, I chose site selection as the application. Site selection is the task of selecting an optimal location for opening new stores. As part of the implementation, a site selection model would be trained on the urban KG. A web app would also be developed to provide a high-level showcase of the model's results. There are 5 ontologies in the constructed urban KG. They are region, business area, brand, POI, and category. First, the region ontology contains region entities, which are geographical partitions of Singapore based on the city's main road network. Region entities can be connected by several types of relations. First, there are border-by relations that connect the regions with overlapping borders. Next, there are nearby relations that connect regions that are within a short distance of one another. Then, there are similar function relations that connect regions with similar POI distributions. Finally, there are flow transition relations that connect regions with significant crowd flow between them. Next, the business area ontology contains business area entities. These business areas are another kind of geographical partitions, but they are partitioned based on commercial zones drawn by a government authority. Next, the brand ontology contains brand entities, which refer to the various brands operating in Singapore. These brand entities can be connected by the related brand relation, which connects brands that are related to one another based on common sense and understanding. Next, the POI ontology contains POI entities. POI stands for point of interest, and in this project, the POIs refers to the stores or outlets of the brands. The POI entities can be connected by co-check-in relations, which represent the geographical influences between POIs. Geographical influence in this case refers to the situation where POIs are often visited consecutively by customers, due to the fact that they are located nearby each other. The POI entities can also be connected by competitive relations if they have overlapping customer bases. Next, the category ontology contains category entities. There are 3 types of categories: Level 1, Level 2, and Level 3. Level 1 categories are coarse level, Level 2 categories are mid-level, and Level 3 categories are fine-grained. These categories are used to classify POIs and brands based on their features and functionalities. The entities are also alternatively called Cat 1, Cat 2, and Cat 3 entities. These category entities are connected by various types of sub-cat-off relations. These relations map lower-level child categories to their higher-level parent categories. Finally, there are several inter-ontology relations that connect entities across different ontologies. First, there are BA-serve relations, which connect overlapping business areas and regions. Next, there are belong to and locate at relations. These relations connect POIs to the business areas and regions that they fall within. Then, there are open store at relations, which connect brands to the regions that contain at least one of the brand stores. After that, there are brand-off relations, which connect brand entities to the POI entities of their stores. Finally, there are POI to CAT and brand to CAT relations. These relations connect POIs and brands to the categories that define them. Next, I'll cover the site selection application that was implemented. As mentioned previously, there are 2 parts to the implementation: a site selection model and a site selection web app. The site selection model chosen was the knowledge-driven site selection model, or KnowSite for short. The model takes in representative embedding vectors of the entities and relations in the urban KG. It first passes these embeddings through 3 GNN-based encoder layers. The purpose of these layers is to convert task-agnostic embedding vectors into task-specific ones. To do this, each layer incorporates the influences of neighboring entities into each entity's embedding vector. The GNN-based encoder layers are modeled as message-passing neural networks. Next, the embeddings are fed into a relation path-based decoder. A relation path is a series of consecutive relations connecting two entities. The relation path-based decoder generates explainable site selection decisions by converting site selection criteria into relation paths. These relation paths are then used to generate link prediction scores between each brand and region combination. The second part of the Urban KG is the site selection web app. There are three main features in the app: a brand index, a site recommendation heat map, and a criteria weightage display. The brand index is the homepage of the web app. It provides a list of brands available in the Urban KG. The brands are arranged in alphabetical order and separated into alphabetical sections. Clicking on any of the brands will direct the users to a results page, where the site selection results of the brand are shown. Each results page contains a site recommendation heat map and a criteria weightage display. The site recommendation heat map is a spatial heat map. The map shows the regions available in the Urban KG and the corresponding site selection scores generated. Regions highlighted with a darker shade of blue have a higher score, while regions in a lighter shade have a lower score. This gives the user a visual indication on whether a region is a good candidate for site selection. The criteria weightage display uses pie charts to show how much of a role each criterion has played in the site decisions. There are two pie charts available, a criteria-based pie chart and a criteria type-based pie chart. We've reached the end of the video. Thank you for watching.